Um, Again, as Scott said, my name is Jason. I work for the State Geological Survey, which is this group of researchers out of the Prairie Research Institute at the University of Illinois. We're a research institute within the university. We used to be with DNR, and we moved into the university about in 2007 or so, and now we're kind of a research branch of that group, doing the same role, just a different source, I suppose. And so feel free to, if as I go along in this, to interrupt me any way you want, and Scott, if you can help if somebody wants to ask a question in the middle of this thing, to help do that and address that. So again, we'll get to that event tomorrow, but before we get to the event, I wanted to talk about a lot of different things. The first thing to talk about is the geology and the history of geology in Boone County, which is something that is actually completely different than that of McHenry County. And we'll get into that, and to the reasons of why we want to map the county. Of course, we're looking towards water resources. We're going to talk about how we're doing it, how we've been mapping in Boone, and then how we're going to map in Boone with airborne technology. So a nice little workflow of a talk, but the geologic history is the stuff that's so fun and exciting to learn about. And I think it's important to know that before we get into really what we're going to do. So the geology of Boone County is a geology that's generally over 100,000 years old. So this is anything that you see at the landscape in Boone County is a function of glaciation, largely, that was over 100,000 years ago. In McHenry County, for example, I hope you can see my mouse. Can anybody confirm if you can see my mouse or not?
Yes.
Sorry. Okay, great.
It's little, but we can see it.
Okay. In McHenry County, that landscape is only about 20 to 30,000 years old. And the processes are the same, but the two events are completely different. So over the past couple million years, we've had lots of glaciations in North America. Boone County is part of the penultimate glaciation. McHenry County was part of the last glaciation. And this is a geologic map that we see. All the pink stuff is from that penultimate. We call it the Illinois episode. And all the green stuff is the Wisconsin episode, which buried all that pink stuff. And just a quick little fact, down here, way down here in southern Illinois, the farthest pink south you can see is actually what the world knows as the southernmost point on Earth in the northern hemisphere that glaciers ever made it during the last 2.5 million years. So Illinois is proud to say that they own that spot on Earth. So if we think about the modern landscape in north central Illinois, this is a map of that landscape, kind of a shaded relief map of that landscape, where we see the Rock River, Pecatonica, Piscasaw, Kishwaukee, Beaver Creek. All of these creeks, all of these are a function of glacial processes and the last glacial events during the last few 100,000 years. So that first event, when I talk about the penultimate, the first event that we see at the land surface that made it all the way to southern Illinois, that's the landscape that we see over in Boone. It covered all of western Illinois as well. And at some point, that glacier, this is kind of a schematic of where that glacier was as it was retreating. At some point, it likely stopped around eastern Winnebago County. And at some point it was there, and water discharge off the front of that ice was running down the Rock River. That's kind of the origins of the Rock River at that time, about 135,000 years ago. And we'll get into why we know it's 135,000. Then as that ice was retreating, it left lineations. We see these lineations up here at land surface up into Wisconsin, all along the northern topography of Boone County. And those lineations are glacial, basically derived lineations, scours and formations. And then at this point in time, a little less than 135,000 years ago, the ice we see on the landscape indications that the ice margins were in generally this form, where Beaver Creek actually was an ice marginal discharge river, before the Piscataquis Creek was ever there, Beaver Creek was actually discharging water from the front of that ice sheet. And then as we retreated even more, that opened up the Piscataquis Creek Valley and abandoned Beaver Creek. So that's why Beaver Creek is about anywhere from 20 to 40 feet above elevation of Piscataquis Creek. And that's one of the only ways we can get those high creeks up there, is to have something holding that creek up high during glacial times. So this is where we have the origins of the Piscataquis Valley, the Piscataquis Creek. We have the southern branch where water was flowing off the ice sheet and forming the southern branch of the Kish. And then we had a period of about 100,000 years of no glaciation. McHenry County was a different type of land surface at that time. What you see is not what it has been for 100,000 years, but Boone County is pretty much what it has been like for the last 100 and some thousand years. And then about 28,000 years ago, ice came back in the next glaciation. And that's what we see in McHenry County. And the more I look into Boone County, I've always told Scott McHenry County is such a beautiful, amazing record of glaciation in Illinois. Well, I'm starting to learn that Boone County is as well. So it's really been fun to work up here. But during that other glaciation, the last one in 28,000 years ago, water was coming off and making a beautiful outwash fan where it's coming out of Lake Geneva and flowing down the Piscataquis. This is where Rush Creek was forming. This is the upper branches of the Kish. This is the upper branches of Coon Creek. So all this water was reoccupying those old water discharge pathways. So all the creeks we see today are a function of where ice margins were, where water was trying to move off these ice sheets and drain towards lower elevations. It's beautiful. And so these creeks can really tell us, the creek geometries can really tell us a lot of stories about that. So how do we know that this geology is 135,000 years old? And it wasn't until kind of the last couple decades where this new technology started coming around, where we can actually take samples of sand that are buried, and if we can collect that sand and not let light touch it, we can date the last time it did touch light. It's called optically stimulated luminescence dating that we've used quite a bit. And this is a picture of a publication that actually Dick Berg, our director, worked on a few years ago, where he went up to Winnebago County and he was trying to date those deposits of Boone and Winnebago County. And one of these deposits, they took all kinds of sand samples and dated these. And on the right here is a record of Ice Age history, and the Illinois episode, that 130,000 year episode. We see that all those dates from Winnebago and Boone County came back right around 135,000. This Wisconsin episode, 100,000 years later, this is the episode that formed the landscape in McHenry County. This is the episode, the Illinois is what formed Boone County again. I'll just repeat it over and over. But it's really cool that we've been able to date those and date them as 135,000. So we know that it's late in the whole glaciation of that last glaciation. Boone County was a kind of a late stage formation of that landscape. That particular Beaver Creek sand that they sampled is basically a shallow aquifer in Boone and Winnebago counties. This is a map of Boone County, the outline here in dark. That Beaver Creek sand is very shallow. It's in the upper 50 feet at most. That is mappable through water well logs, and Dick Berg mapped it here in this publication, where the darker color is where it's buried and the lighter orange is where it is very close to land surface or at land surface. So these are the places where they sampled and were able to date that. And with our new mapping, we're going to try to refine this map even better, really understand not only where this aquifer is, the shallow aquifer, but what it's like, how thick it is, where it really is and is not apparent. So it's an exciting new technology that is being used to figure out geologic history. Another thing is LIDAR, for example. I'm sure many of you are familiar with LIDAR, but it's basically laser scanning of the Earth's surface to get really high resolution landscape models. And so down in the Kishwaukee River Valley, we have these beautiful, beautiful terraces, which are telling us the history of the glacial history. The oldest terraces, these highest terraces, for example, you can see these flat areas. These are old river plains, as we're all familiar with that being part of this Kishwaukee River group. The highest little flat plains are the oldest terraces and the oldest levels of where the river used to be. And we have all kinds of different terrace elevations in the Kish Valley and in the Piscasaw Valley and the Beaver Creek Valley. Um, so it would be cool if we can get the resolution with that optical dating, to start dating some of these terraces. But these terraces help us understand the history. The modern Kishwaukee River did not form this whole valley. So the oldest terraces in this whole big valley were formed during glacial events when water energy was uh, much, much greater. Glaciers were within a mile or two of this site, and we had these huge outwash events happening. So it's just beautiful that LIDAR can show us all the different crazy pathways of the old rivers and the modern Kish. We see all the cutoffs and stuff in the beautiful LIDAR images. Also with LIDAR, which is something that Dick Berg didn't used to have when he was mapping this, uh, we can see different places where ice margins were. This is a landscape model where this is the Kish, this is the Piscasaw coming in, Kishwaukee River, this is the gouge of the Kishwaukee. And south of Belvedere, we see all these ridges, these linear ridges. This is a ridge here that is being mined out for sand and gravel. This is a ridge here that's a topographic ridge. We see all these little ridges everywhere, and these are old ice margins. We know that these are ice margins because of the materials that make up those ridges, uh, and just knowledge of the glacial history. So these things can help us understand where different materials are and what the geologic history is during deglaciation and what the landscape really tells us. And these are things that weren't available the last time Boone County was mapped geologically. So the last time was by this gentleman, Dick Berg, who is going to join us tomorrow. He's our director. He's been around and been an employee for us for 50 years. But back in the 80s, he mapped the geology of Boone and Winnebago counties. And back then, these were the types of the old publications where we had these black and white publications, and they did a great job setting up the geologic framework of what we understand about surface geology and subsurface geology. I'm going in and starting to refine that with Dick's help, refine that geologic map, refine the model based on LIDAR data, new data, and this will be part of what we're developing here in the next couple of years. We're also trying to read and interpret what's below ground. This is an old cross section from Dick Berg in the 84 publication. And I'm going in to try to kind of refine those, reinvigorate that work and figure out new ways and better ways to make better cross sections, more refined cross sections. This is one that's across the central part of Boone County from here to O prime, using real data. These are real water well records. These black lines are water well records that we use those information to create cross sections. So Piscasaw Creek is here. We have our own borehole right here. A few holes get down to the bottom of this, what we call the Troy Bedrock Valley. So this bedrock valley is incised into the bedrock and filled with glacial material. And this is a key component to the water resources of Boone County, this Troy Bedrock Valley. It holds the key to the secrets of the water resources in general of not only Boone County, but potentially more regional water resources. And so part of what we want to understand is how deeply this valley incised into the sandstone below. So this sandstone is a big regional aquifer that's being used all over Northeast Illinois. Belvedere uses it. Capron uses it. Rockford, Milwaukee, all kinds of towns and municipalities across Northeast and North Central Illinois and Wisconsin. So it's a highly used um, aquifer that is stressed, uh, is very stressed. And Boone County is a place where potentially shallow waters are connected to that sandstone aquifer. And we've been trying to figure that out for years of really how connected it is. And that Troy Bedrock Valley, this is an illustration here on the right of the bedrock surface of Boone County. And that Troy Bedrock Valley is shown in the darker areas where there are little tributaries that go into the deeper valley. And all these little dots on this map are private water wells or municipal water wells. And the colors on the map tell us what materials they're getting their water out of. So a lot of Boone County, if we see up here, there's sand and gravel, limestone and sandstone. A lot of Boone County private wells are getting their water out of the limestone. So they're tapping down into this shallow rock and finding fractures in the rock, and the well driller can get water out of it. A lot of them are sand within you can see a lot of these orange dots up here. Those are a lot of getting water out of that Beaver Creek formation. A lot of water's coming out of the Troy Bedrock Valley. A lot of Belvedere's water's coming out of the sandstone. So it's a complicated relationship. We're trying to figure out how all of this ties in to not only the local water supply, but also the regional water system. This is a map of that water system of that sandstone aquifer. That sandstone aquifer is very stressed down in the Chicago area, down the Joliet area, and that stress actually collects, and it's this collective effort of stress that includes Rockford, Belvedere, McHenry County, and all the way up into Milwaukee. Everybody's contributing to it. The highest contributions and the highest stress is down in the Joliet area. So they're dealing with that. Yeah.
Before we get too far from the last slide, and if you're going to be talking about it further, I apologize for interrupting,
No
but I think it's an important distinction to make that there is connectivity between the sand and gravel and the limestone aquifer below it. So the limestone depends on infiltration through the sand and gravel to fill the cracks and fissures in the limestone. Is that correct? And if so, can you just kind of elaborate on how that that interconnectivity is and the relationship between land use and recharge to the sand and gravel and the limestone?
Yeah, sure. So it's not an easy system for for sure. Here's one example where I have an arrow of all these blue arrows are, for example, potential water flow in the groundwater system. One of these is water flow from the limestone into the glacial materials, and it can go vice versa, depending on where water is moving, where the gradients are. Slope of the water table is driving a lot of water flow. Pumping wells are driving a lot of water flow and can change water direction. So yeah, water in general, recharge to the shallowest aquifers are from precipitation and local precipitation, for example. In general, we can get precipitation over here that can find its way through sand lenses. And ultimately, Piscataquis Creek is a place where groundwater can discharge. It's probably more of a local discharge. It's not discharging stuff that's very deep, but water does generally flow from the highest parts of elevation into streams and discharges into streams. The regional water flow deeper is recharged by, sometimes it can be recharged by places where this incision occurs, recharged by places where there are fractures within an upper unit that can allow water to flow through, and other places where this sandstone is actually exposed at land surface, which this is a map of here, where the sandstone in McHenry County Boone County is 300 feet deep, but it's exposed in Wisconsin up in here, exposed at land surface, for example, or exposed at close to land surface. And that's where that particular rock unit can recharge as well. So it's a complicated system of where water can get into the system and trying to understand it better. And that's where 3D geology can help us communicate that better and help us build models to figure it out better. I think that can help answer your question a bit, Scott.
Yep, thanks.
So regionally, again, this is a cross section of those rocks in that sandstone unit. This little SP unit here is the St. Peter sandstone, we call it, and it's kind of connected to this IG, which is the Ironton Galesville. And again, this Troy Bedrock Valley is a significant valley, along with the valley in the Rock River Valley, which also incises down close to that sandstone, if not in the sandstone. And so we're trying to figure out really how deep that incision is. And people have been trying to study this for a long time. Back in the early 2000s, late 90s and early 2000s, the USGS was actually doing a pretty significant groundwater modeling study in the area of Belvedere. And Pat Mills, which is a colleague of mine, I've known him for years, had the same question, and some of his conclusions in their reports. They had many reports from the early 2000s saying that he had question marks down here too. His schematic here on the right-hand side is, how deep does this incise? Is there a confining unit above the St. Peter sandstone, or did it incise all the way down? We really don't have a lot of information that defines that. And that's where we're trying to find other ways to try to define that incision. That incision is really one of the major ways that shallow water, can be connected to the deeper sandstone, and also connected to the shallower limestone as well. You see, Pat Mills' arrows are going all over the place. So he's trying to estimate fracturing and connectivity between the shallow glacial stuff and the limestone. And we do see, oh man, I can go on forever. I'm sorry. He was defining bedding plane partings in the limestone, and we can see probably where those partings are, where these water wells over here on the left are stopping. So water well drillers, these are not all drilled at the same time. These are probably drilled decades apart, but they're all stopping in zones within the limestone that are likely fractured. So those are places where water is probably moving quicker through Boone County rocks than other places. So this is an older map, about 25 years old now, of an estimate of what the bedrock surface looks like, where limestone's on the outside of that valley incises down into the sandstone. And this is an interpretation. This is not a measurement. This is an interpretation of, well, this interpretation shows that Troy Bedrock Valley incises all the way down into the sandstone, all the way across the county. The data to support that, we have about 20 or less borings that actually go all the way down to rock. And those are water well records and a few of our own borings, and that's about it. So there's not a lot of information that actually defines the geology of that valley and the geometry of that valley. We want to try to do better. So in the last few years, we've been using some other funds to map in Boone County. We've drilled 3 of our own holes. 2 of those holes got down into the bottom of the valley. One of them was on the flank of the valley. And unfortunately, drilling is not a perfect science. We drilled both of these holes that were supposed to be right in the middle of the valley, and they were deep as heck, but we couldn't get enough recovery in samples to really understand what that bedrock material was. It was very disappointing. We tried our best. We're going to try again. But we know those are very good control borings on depth of the bedrock valley. This particular boring is one we did, this one in the middle here at Funderburg Conservation Area. We were able to drill through and collect rock sediments all the way down to rock. And here we knew we were going to hit some limestone. So we did hit the limestone rock here at a shallower depth. But we got through a lot of the sand and gravel, which are the shallow aquifer units. We had a confining unit, which is an old lake sediment, and then we hit more sand and gravel down underneath that. And we'll see how that looks in cross section. That particular hole was right here that goes east-west across the county. And so this lake sediment's been recorded before in other test borings and other water wells, this sand and silt. So that can be a little local confining unit between sand and gravel aquifers. But it helps us also understand the geologic history of where there were active rivers and lake sediments and active ice throughout the history of this Troy Bedrock Valley. So these control borings are really good to help us constrain our geologic interpretations. Another way we've been mapping in the last 3 years, we've been using a lot of students, and this mapping is done with other federal grants. The USGS gives states money to map in their states, and so we've been using 3 years of money from the feds to map specifically in Boone County. So it's been exciting. This has been kind of still a way to gather a bunch of data that can help us with the airborne project. This is a way where we can set out an instrument, this little yellow box. It measures random seismic waves all over that are floating through Earth. And the map on the right on the left is all of those measurements, where the biggest and reddest measurements are the deepest measurements of where the bedrock surface is. And it's not a perfect measurement, but it's certainly something that we can use as a guideline to better define where the Bedrock Valley is. So we've had over 400 measurements in the last 3 years in Boone County, and we've done these profiles across the county, and you can see where the reddest stuff is in where we are pretty sure the Bedrock Valley is. So it's confirming the geometry, our understanding of that valley. And it's a really nice tool to help us understand the bedrock topography. So we've been redefining that bedrock surface. This is an old bedrock surface from 25 years ago. This is a new bedrock surface which has better defined tributaries and better defined little fingers because we have new data. This is the difference between those two interpretations. And then here's some of those, what we call HVSR, those seismic measurements to help confirm our interpretation. So that's part of what we're doing as a baseline, again, for building this airborne project. We'll get into the airborne project, I promise. I'm keeping an eye on the clock here. We've also had all these students and other collaborators go out and work seismic crews with us. And this is a great collaboration between Illinois State University with students, our own colleagues. Kisa Makanyamale has been great. She's my colleague. She's on the call. We are co-leading this project, and but also the Boone County Conservation District has been wonderful with allowing us access to sites. So this is along Long Prairie Trail, right there along Route 173. We ran 7 or 8 miles along the trail. Our student crews were working in the middle of the night sometimes to avoid traffic. So they have a bunch of geophones behind a truck and can measure seismic waves in the field and then come up with profiles of squiggly lines that myself and geophysicists can interpret of where the bedrock surface is. So I don't have full interpretations of those, but these are some of the data. We can also use electrical methods where we put out a bunch of stakes in a profile and we connect them with wires and we run electricity through it. And we come up, again, this is along Long Prairie Trail, and we can come up with these pictures of electrical properties of what's below ground. And these can correlate, we can correlate those with borings that we have. This is the boring we did at Long Prairie Trail where we start to see, oh, we have a clay unit in here in the boring, and this blue stuff is probably correlated to that clay, and anything red and orange is correlated to more aquifer type stuff, gravels, sands and gravels. So down here, we hit a thick gravel in the boring, and we see this red stuff in the geophysical signal. And this is the same technology that we're going to use in the airborne project. This is just ground-based, and the airborne is using electrical energy to do the same thing. This is another one up near Capron, west of Capron along North Boone School Road. We ran a transect there, and we were able to clip the edge of that bedrock valley. It breaks off like a cliff. We didn't get that deep, but we saw the edge of that bedrock valley here on the west side. And we also picked up where that sand was, that Beaver Creek sand, that shallow aquifer that many shallow wells are actually tapping. Now, these are well records that are blowing through that sand to get to something deeper. But anyway, these different technologies can really give us good two-dimensional pictures and three-dimensional pictures of what the subsurface geology is. So after all those that work um, over since the 80s, this is all the data we have for Boone County. And so every little dot you see, the tiny green dots, those are water well records we have in the county. All those other colorful dots are those seismic measurements we have, which are just 1 point pings on the bedrock surface. All that geophysics that we ran with all those students is kind of up here near in the north east quarter of the county. But all those data we still have these huge data gaps. Basically, everywhere you see yellow, we don't have data. We just don't for the subsurface. I mean, I started drawing these boxes and I could draw those boxes forever. But so what do we try to do about that? I mean, this is another illustration. This is a video that I just wanted to show of some 3D visualization software we have to kind of illustrate the vast amount of data we don't have in the subsurface. So this is a software we can kind of fly through the subsurface. This is Boone County. These are all those well records visualized in 3D. That's the bedrock surface, that gray surface that popped up. These are, every stick is a water well record that's coded with different colors for showing what the different geology is. We're below that bedrock surface now. Now we're going to go out into that Troy Bedrock Valley. And within that Troy Bedrock Valley, we have no data. We have a few of those borings. You can see some of these deep borings. And we have a few of our own borings, which are kind of the fatter cylinders. We'll get into now we're right in the middle of that Troy. So we see a few, oops, oh my gosh, I'm so sorry. We see a few of the deep borings. We see a few of our own borings, but when we visualize the data and try to really understand what data we have in the subsurface, we don't have a lot. We have lots of shallow stuff, but not a lot of deep stuff. So this is just a way not only to be cool and fly through the subsurface with computers, but to illustrate really how much data we don't have in the subsurface. So how do we figure this out? One way to figure out what's below ground is to go above ground. We take to the air, and a technology that Kisa has been developing her expertise in over the last 10 years or so is airborne electromagnetics. This is a technology that's kind of been developing over the last 20 years or so. And another colleague, Don Kiefer, who's on the line, has been critical of developing this program, at least with internally at the ISGS. What it's used for is to basically acquire the highest resolution of geophysical data that we can get. It's not physical borings or anything, but geophysical data is one way that we can image the subsurface. And we use airborne because it's fast, it's relatively cheap, and it's high resolution. And we can develop from those data, we can develop models and integrate those geologic models with groundwater flow models that simulate the physics of groundwater flow and the real physics of systems like that. But they got to get the geology set up first. How does this system work? Well, you have this helicopter. It's towing this big loop, which has electrical wires around it and a battery, and it can eject an electrical energy straight down into the subsurface down to about 500 meters. And when the geology interacts with that energy, it comes back to a sensor on the instrument and can measure differences in time and differences in energy and create these images of the subsurface. So this is a particular image from Champaign County, and where we have shale bedrock, which is very conductive and very blue, and we have other stuff that's less conductive and more like sand and gravel aquifer material that's in red and orange. And we have borings to kind of test that, and then we use these data to interpret the geology in the subsurface. Amazing technology that it's the same technology and the same principles that we use on the ground, but in the air we can do it a million times faster. So I want to take you through an example we've done in Champaign County, just a bunch of flip through slides to show what the data look like and what we're expecting the data to look like in Boone County. This is all of Champaign County. So Champaign-Urbana here is this blank spot in the middle. This is just because we can't fly over cities. But this is down where U of I is, where we are, where I'm sitting right now. And we have a similar situation in Champaign County where we have an aquifer flowing, or aquifer in the subsurface that's kind of northeast to southwest through the county. And with this data set where we flew back and forth, back and forth, back and forth across the county with this helicopter, we can start to see how this aquifer, we can see and image that aquifer in the subsurface and start to reinterpret where we thought that aquifer was and what it's like. We've never had data resolution like this before, ever. And we're also learning about what's below the aquifer, what's above it, all the materials above it, where those are distributed. It's been a really wonderful tool so far in Champaign. So to look at some of these data, we can look through them, look at them in profile view like this, which is pretty. But to really analyze the data, we can take a horizontal slice through the data. And really start to see how the geology changes with elevation, for example. So let's flip through this a little bit. So in the upper left here is a generalized cross-section of where we have this Mahomet Aquifer filling a bedrock valley, similar to Boone County, and it's capped with clay, this green stuff. And we're going to look at some of the data through these horizontal slices, and this red line is going to tell us where the horizontal slice is. So this is a slice that's way down below all the aquifer, and this is in the bedrock. So everything blue is a shale, and the red is a limestone. And then we're going to move up. You see that red line is moving up through the sequence. And as we get into the middle of the Mahomet Aquifer, we see that this aquifer is bifurcating, it's splitting across through the county, which we kind of knew was there, but now we're really starting to define exactly where it is. We see these beautiful defined boundaries of exactly where we know that aquifer is and where it isn't. And as we move up through that system, we start to see channels where these are little channels of sand that are dumping into that aquifer from higher up. These are details that we've never, ever known were there. And as we move higher up, we get out of all those sands and we're more into the clay cap, where we get into the greens and the blues, and finally we're out of it. Let's see it again. Let's go up through it. We see that aquifer come in. We see channels. It's just changing the way we perceive the geology for sure. Because before, all we had were borehole records. This is another little example. I think I have time to go through this. I'm almost finished. This is another example of using ground-based geophysics to try to find water supply for a little town called Homer. So this is the little town Homer outside Champaign-Urbana that needed a new water well. So we went out with ground-based geophysics in the 1990s, and they did all these surveys along roads, and they found a little blob up here where this Hatcher pattern is of sand, where they thought was sand. They drilled a couple wells, and Homer then got 2 new wells that are supplying about 1 million gallons a year for that little town. Beautiful, perfect. And that project probably took at least, I talked to the person who ran that project, it took at least a couple months to plan it, to gather the data, a few more months to interpret it, and then finally get a report out. And then it took probably another year to drill the wells. So in Champaign County, we flew the airborne geophysics in 7 days. The whole county took 7 days. KISA processed all these data and came up with a model. And now we know exactly where that sand is, that channel. They thought that channel was going to the southwest a little bit, and we can track that channel with the geophysics all the way into what seems to be contributing to the bigger aquifer. That channel is, we can see that beautiful channel in here. So it's just an amazing tool to open up our eyes to what the subsurface is, and saves us a lot of time and a lot of money and a lot of effort. So, and it's changing our perception of what we thought the Muhammad Aquifer looked like to what it probably is closer to looking like because of the data density that we can collect. Cost efficiency too. In Champaign County, that project total cost, the Champaign fronted about $500,000. Champaign County did. We're contributing another 500,000 at least in staff time and state funds for a 2-year project, probably 2 to 3 year project, costs 1 to 1.5 million total cost of contributions. If we were to do the same thing ground based with the best resolution, it would take at least 12 years and cost probably 7 to 10 million. And that's with student crews. I did do this back of the envelope. That's student crews with never a day off ever for 7 years or 12 years. So it's not really reasonable. And these are some of the ground-based tools that we can use. These are definitely valuable, and they're used to ground truth the airborne data, which we will use in Boone County as well. So our plan in Boone, this is something that Kisa and I have worked on for a long time, and Kisa is really the expert on the technology and the approach to airborne methods. Our approach at Boone is similar to Champaign, where we're going to fly transects across the entire county at 650 meter spacings. So that's pretty tight spacings all the way across from county line to county line. We'll also have some angular tie lines, as we call them, to try to help us understand the relationships between those profiles. And tomorrow starts that event. This is one of our events down in Champaign where we had a group of people come out and then we did a demo. This is what we're going to do tomorrow. But some of the things we want to find and want to map in Boone is, again, that shallow sand up here, which does supply a lot of water to domestic homes and farms up in northern Boone County. And it is a critical part of recharge to deeper aquifers, is the shallow sands. We want to define better the bedrock valley and tributaries, even though we have defined it better with new data. This is a resolution of data that is unprecedented. So we aim to really be able to define exactly where that bedrock valley is and how deep it is. And this is the key, is trying to figure out how deep this thing is. And that helps us understand how exposed, how connected these two major aquifer units are, the aquifer systems are, the shallow system and the deep system. So those are kind of 3 of our main goals that we're trying to figure out with this. The schedule, this comes right out of one of our reports and proposals that I think we're pretty much on schedule. We were developing communication with the county, and the county is paying for this. And we're certainly contributing a lot of state funds with our salaries and other resources to this as well. But we're going to start acquisition tomorrow. So we'll do a demo at noon tomorrow at this event. And that will be, once the helicopter takes off and does the demo, they're going to start and just leave and start collecting data. So it'll be awesome to see. But we're anticipating about a 2.5 year project. Final reports and deliverables we're anticipating in winter, spring of 2027. Because it'll take about a year to process all these data, and then about another year to interpret it all in high resolution. And then some of the deliverables we're anticipating is certainly some maps of either the geology or aquifer recharge potential, all the digital files and all the digital data with it, and then certainly comprehensive reports, and also interactive 3D online resources, whether it's a geologic viewer, interactive data sets, interactive planning tools, things like that we can develop for Boone County and for other people to use to make it more effective and make the results more effective. So just to end it here, this is one of the announcements that we've sent around as an email for this event tomorrow. That's going to be at the Wings and Wheels Museum at the Poplar Grove Airport. And I think most of us here know about it. But we'll have an open house at 10 a.m. where myself, Kisa, and other colleagues will have booths along with other water resource scientists or specialists in the area that Scott's organizing and Dan Kane have helped organize. It'll be an awesome event, and we'll have this demo at noon with some free food. So it's exciting.
Yeah, the
So thanks for
invitation
listening.
the invitation and link to the RSVP were included in the emails that were sent out. So if you are interested, please RSVP. And I didn't mean to cut you off there, Jason.
No, it's
Did you
totally
have a
fine.
closing comment?
No. I just, I mean, I can have closing comments. Let's see. Just thanks a lot, Scott, for the opportunity to give this to the group. And I was reading about the partnership online a little bit, your website, and it's an amazing partnership with DNR and your colleagues, and it sounds fun. And I just wanted to offer too with PRI, we do have lots of data resources like LiDAR, uh, aerial photography coverages, aerial land use coverages, vegetation coverages. We have all these kind of digital data that if you guys are interested in using any of those data or having those as a resource, we could help you with that. Just FYI.
Okay. Well, thank you very much, Jason. In my email that I sent out for this meeting, I commented that if you attend one of Jason's talk, you're going to walk away with a higher IQ than you started with, and I think that's been proven true again today. I learned more about McHenry County's geology in your opening slides than I have in years.
Oh, great.
What I talk a lot about is, this job is I'm in a constant state of being humbled. Every time I think I start to know something, I learn all the things I didn't know. And so I'm always like, each step forward, there's a whole new mountain I have to climb. So thank you for helping to keep me humble. But
Sure thing.
I did have a question. I'll start out with questions as far as the three-dimensional visualization. Um, one of the things I'm excited about is you're going to be able to get greater granularity down into that limestone bedrock. Are you actually going to be able to make out cracks and fissures in that limestone and help understand flow paths better in the limestone bedrock?
No, not, I don't think likely. No. So
Okay.
that's a resolution that's going to be likely not picked up with geophysics. We can explore other ways with maybe some more high resolution ground-based geophysics to try to pick those up. But with electrical methods, it's very hard. I think it'll be very difficult to try to pick those fractured zones up unless there's something electrical in that we don't know about. Electric, those zones may be, I would hope those zones may be a little more shaly, which means they're a little bit more finer grained that has these fractures in it. And maybe we could pick that up. And those, with this technology, it's things that are electrically different, geology that's electrically different that we can really resolve better. And so hopefully we can see potentially some shaly zones in that limestone. And if it lines up with where people are getting wells, maybe they could really help answer some questions that way.
Okay. Yeah, well, I kind of figured it'd be tough to get that level of resolution, but I'm really excited to see what this ends up looking like. Um,
Yeah,
so
yeah.
I'll open it up to the group. Go ahead and unmute yourself and ask away.
Hi, Jason. This is Amy.
Hi, Amy.
I really appreciate your presentation. You're always a really good presenter, and I learn a lot of stuff, so it's great.
Oh, thanks.
In the chat, I just wanted to point people to USGS did the same thing in partnership with the State Geological Survey and the State Water Survey. So all this collaboration between federal, community, and state is really nice. We're getting the same data for the Illinois River Basin. And
That's
I
right.
put an image that tells you the whole coverage of that. And so Boone County wasn't included in that because they're not part of the Illinois River Basin. But so this is going to help connect those dots and provide even more data for the whole state, or most of the state, I should say. So just wanted to point people to that. And yeah, thank you again, Jason, for presenting.
You're welcome, Amy. Thanks for mentioning that.
Mhm.
And so, yeah, we've just to add to that a little bit, the USGS project is flying at a more coarse resolution because they're doing the whole Illinois Valley, including the Fox up into Wisconsin, I believe. So it's a coarser resolution, but it's going to be an amazing project to resolve similar aquifer geometries, but just not as a high resolution as we're doing in Boone.
Amy, in that image you sent, is it where those red lines are, is where the flights are occurring? Flight paths?
Yes, that's what he means by coarser resolution. So in his example, it was much closer line spacing, but this is much wider because they're covering a much wider area. But still, they're already learning so much more with that data, and that's already improving some of their model outputs. So it's been underway for the past couple of years now, and we're getting into the analysis part and the good stuff.
I see a question from Durs Anderson. Can you imply connection between different subsurface water by looking for consistent water chemistry?
Yeah, that's certainly not part of this project, and I don't think we can resolve water chemistry. Well, we'll have to collect some. We won't actively collect water chemistry measurements, but if we can gather some water chemistry data from previous studies or anything, I think Pat Mills has done some water chemistry stuff with his USGS study back in the day. But that's something that we really want to look into as well, is what these signals can help us understand about water chemistry. We're exploring the same kind of thing in Champaign County as well. It'll be more regional kind of water chemistry. Nothing at the level of ejection points in a stream, in a spring or anything like that. But regional water chemistry could be something that we can maybe see. But it's something we want to explore for sure.
Cody Book has his hand up. Cody, you want to unmute yourself and go ahead and ask your question?
Yeah, are you going to be able to lay this next to McHenry County's map and cross tie them, being that was 10 years ago? Technology's changed immensely. Is that going to be useful at all, crossing the county line?
Oh, yeah, for sure. So even though we didn't fly McHenry County, McHenry has a lot more data, a lot more boreholes than Boone, and it has a better geologic record and different layers. The geology is actually a little bit more simple. Even though it's a complicated mess in McHenry, there are certain geologic units and layers that are smoking guns to where we know what the geology is. Boone County doesn't have that as well. So anyway, we're very confident in what we mapped in McHenry, and we're very confident that we can extend those interpretations into Boone and help us with Boone for sure. If that's, I think that answers your question, but.
Just to clarify, it's a complicated, beautiful mess.
Oh yeah, not a mess, not just a mess.
Go ahead, Cody.
No, I was just going to say that was what I was looking for an answer.
Yeah. We're going to tie it all together for sure. That's what we're hoping to do.
And along those lines, Jason, on the online viewer, then will the online viewer be able to be combined, both of them, McHenry and Boone, so that you can seamlessly go using that single app from county to county?
Yeah, that's our goal. It's not. We got to figure out a way to do that. But we have models for Lake, McHenry. We will have for Boone. We have models for Kane, Will County, and we will for DuPage and Cook within the next. So we already have everything modeled except for DuPage, Cook right now, and Boone.
Huh.
And so we have all these 3D models that we need to merge together. And ultimately, if we can get the online tools robust enough to manage all those data at the same time, heck yeah, we want to do it. It's, one of the goals of PRI is to try to do kind of what do they call it? A digital twin kind of thing,
Right.
you know? And so, yes, for sure, we want to merge them all together. Right now, they're all separate models that are on viewers, but we need to get those merged. Do you guys want to see the model real quick
Uh,
or
sure.
not?
Yeah, no, I think everybody would benefit from seeing what the end product looks like.
Well, this is one of the end products. This is McHenry County's model, where there is a 3D viewer, and the 3D viewer it's fine, it's fancy, it's pretty bells and whistles, but the applicability of this is being able to draw a cross section anywhere you want it, and then that cross section comes up here uh, at the bottom. And again, this is a prototype kind of model where the different colors show different materials, but anything you see orange or brown is aquifer material. And you see where exactly you are along the cross section as it tracks it on the 3D map view. So you know where you are. This is the north branch of the Kish. Then we get into the actual Kish Valley, and the Kish Valley has about 60 feet of sand and gravel until you hit clay. And then sometimes you have another sand below that. And you can draw arbitrary lines or arbitrary boreholes anywhere you want to dissect the geology. The other thing we just added to this one actually is a water table.
Ah.
So again, this is a prototype. This is actually built by one of our Polish colleagues, and we want to migrate our viewers to his tool. But this is a water table. This is the shallowest water table of the shallowest aquifer in McHenry County, as modeled by the Water Survey. And we can see that as a blue line in the cross sections, but also you can see it in this as an actual three-dimensional surface. And we can turn these surfaces on and off. Oh yeah, and it's slow. So again, I keep saying the word prototype. This is where I'm working with our Polish colleague Ziggy to try to get this thing speeded up. But this is basically a 3D view of that water table. And then you can see the water table intersection here in the cross section. And this is a modeled water table by the Water Survey. So this is one way that I know, Scott, you've kind of used this type of a viewer before to communicate with municipalities, where you can go into a city boundary and do a virtual borehole. That's over here on the left. And if somebody wants to drill a new well, they can explore their property and see what the estimated geology is at that property and what the depths are. And the next steps into this are developing and bringing in those water resource tools or the recharge potential tools and the maps, and incorporating that into an online viewer like this, which is quick and easy to use.
This is mind blowing. The applicability of this is it really bends the mind, and I think can be very useful for planning purposes for whether you're a homeowner, well drilling company, or a business. And just to give people an idea, the way I've been using this is typically if I'm looking in an area, I'll start out making a transect going from west to east, then north to south, and then start looking at things diagonally. And so you really are getting a three-dimensional perspective of the geology under your area of interest. And you can be looking at both where the aquifer is and start getting a better sense of where the recharge to those aquifers are. And the model that we've had access to has completely influenced my perspective of our geology and aquifers in the county. And when I give my presentations at tabling events or conferences, people are sometimes almost in tears because they had no idea where their water came from. And, having this type of visualization really drives points home in ways that you can't just convey through words alone. So these visual tools are invaluable in helping to use them for planning or even just educating on where our water actually comes from. And this new model is really blowing my mind, and I'm looking forward to
Yeah,
seeing
good.
it in full action. Cody, you had your hand up again. You want a follow-up question?
Yeah, I actually have a couple things. I think it's the map we're looking at right now is water table. Northwest corner of McHenry County. I think it's northwest. It's like a purple that's nowhere else.
Up in here, can you see my mouse?
It'd be a purplish color that's nowhere.
Northwest
Like
is up here near Harvard. Yeah.
Yep. What is that? Why is that so much different?
Oh,
from
this
the rest of the
purple.
county?
Oh, the purple way up here in the county. Yeah, that is a clay type unit that is it's a glacial clay that was deposited. It's a moraine, just like Marengo Ridge, but it's an older moraine. And this moraine we see in Boone County as well. We call it Capron Ridge, but it's a cap clay that forms a landform called a moraine that constrains the Rush Creek and constrains the Piscataquis Valley. This is the west edge of the Piscataquis Valley as it enters into Boone County.
Okay.